So today we have a nice geometrical question. The given data is very simple. The point you have to note is that this arrow signs means the lines are parallel, not equal. The area of these two triangles are given 5 and 8. You have to find the area of this middle triangle, that is triangle BED. So let us see its solution. So first of all, as the area are 5 and 8, what if the area is 13 and 17, 25 and 56? Means if the area differs. So we have to just think like a general solution. So for that, I am going to keep the area as some kind of variable a and b. So let the area of this is equals to a and area of this is equals to b. And what we have to find is the area of the triangle BED. Let it be also equals to some kind of variable x. So what we have to think is that the area of this particular triangle, that is x, we have to bring it in some kind of equation, or else x in terms of this two area, that is a and b. So you have to bring the area of this particular triangle x in terms of a and b. We have to keep this in our mind, and when we will get that particular equation, as the area of a means a is equals to 5 according to this particular question, and b was equals to 8 according to this particular question, we will just input these two values to get the value of x. So let us see that. So first of all, I am just removing this thing and discussing a theorem that if there are two parallel lines and from the same common base, these two lines are parallel, let this be a line segment on it, and let us name that as P and Q. So if from P and Q I draw a triangle, that's triangle CPQ, and another triangle from that same common base as MPQ, then area of the triangle CPQ would be equals to area of the triangle MPQ. So yes, this is the thing, that between two parallel lines, there are two triangles from the same common base, their area is going to be equal. Its proof is very simple. It's all depending upon that two parallel lines have the same perpendicular distance. So area of that both becomes the half, the same height and the same base. That is why they both have the same area. Why I am discussing this theorem? Because in this particular question, the only eye-catching data was that these lines are parallel. You can also have a note that these two things were only given, that the lines are parallel, nothing else. So we have to ultimately utilize that thing only. So first of all, I am just removing some of the things from the diagram, that is b, x and this thing, and concentrating on the things that are given. So from this point, that is point E, I draw a line segment to the point C. So from E to C, I draw a line segment, and note that BE is parallel to CD. These are the two triangles standing on it, that is the first one and this is the second one. So they are going to have the same area because of the theorem I just discussed. So let us make them as some kind of variable, means writing them down. So the triangles are triangle BED. So area of the triangle, that is triangle BED, is going to be equals to the area of the triangle, that is triangle BEC. So that is equals to area of the triangle BEC. So writing it over there, BEC. Similarly, we have another pair of parallel lines, that is this one parallel to that one. So from there we can get something else. So I am just removing this line. Yes. So that two lines are parallel. I draw a line from the point A to the point D. So there from A to D I draw a line segment. So this is the parallel line. This is the first triangle standing on it, and this is the second triangle, and this is the common base. So area of this is going to be equals to area of this. So first one is the area, that is equals to BED. Yes, the first triangle is triangle BED, and its area is going to be equals to the area of the triangle ABD. So writing that also in kind of equation. So secondly, we got that area of BED is equals to the area of triangle, that is ABD. Now these are the two areas we got equal. Now what we will do is bring them down in some kind of equation. Not equation, means their formula, that area of triangle is equals to half base into height. So I am going to write that thing in that. So I am just removing this theorem because I need the space. So this theorem I removed. Yes. Now in this diagram, let us join some kind of lines. So first line I am joining is E to C, that was joined in to obtain this first one, that is area of BED is equals to area of BEC. To obtain that, we have done that. So I am joining that line. So let this be the height from point E to the point, means to the base BC, or we can say the whole base AC. I draw a perpendicular and let us name that as point D. So if that is equals to the perpendicular, then area of this particular triangle, that is triangle AEB. So let us name the base also. From A to B, let it be equals to K. From B to C, let it be equals to L. So area and height, let it be equals to H. So area of the triangle AEB is equals to half the base is K, and height is ultimately going to be H. So height is H, and AEB was marked as a variable A in the beginning, so that is equals to A. Similarly, area of the triangle BEC in this same diagram, the area of the triangle, that is triangle BEC, is going to be half the base is equals to h, and sorry, not the base, the height is equals to h and the base is equals to L, and that is equals to the area of the triangle. The area of the triangle is BEC. Similarly, I have to draw another perpendicular, so let us do that. So now changing the color to green. Yes, we have to, for this we have to extend the base BC, and here's the perpendicular drawn. Yes, let it be clear so it looks nice. So here's the perpendicular drawn. We have just extended the base and draw the perpendicular, and let this be named as capital H. So if that has been named as capital H, we can have the area of the triangle, that is triangle BDC. So area of the triangle, that is triangle BDC, is going to be half, its base is going to be L, and now its height is going to be the capital H. Remember, if there is an obtuse angle triangle like this way, obtuse angle, and this is the height, we extend the base to draw its height, let it be equals to dotted line. As we draw its extended base, this is the height H and this is the base A. Then the area of this obtuse angle triangle is going to be half of the base and that height. It's like to find the area of an obtuse angle triangle. So as that triangle is a kind of obtuse angle, so height is going to be H and base is equals to L, because we are taking the triangle BCD. Similarly, we can have the area of the triangle ABD, because that is again going to be an obtuse angle triangle, and from its top vertex the height has been drawn, so we can have its area also. So now we have that area of the triangle ABD. Yes, let it be clear. Yes, it's ABD. So area of the triangle ABD is going to be half, its base is K and height is equals to H. And I can see that area of the triangle BDC was taken as B in the beginning. So area of BDC is equals to B according to the beginning, and area of ABD is area of ABD as it is. So area of ABD. So as I told you, we have to just have the area in terms of their formula. We have just derived this 4 over there. And now we were having this two equation, that area of BED is equals to area of BEC, and area of BED is equals to area of ABD. So as we can find, BED was the thing that we have to find. Yes, BED has been marked as X. So area of BEC is ultimately going to be equals to X. And in this we were having the area of BEC in the terms of formula. So that is equals to X. Similarly, over here we were having that area of ABD is also equals to BED. BED is nothing but it's X, so this is also equals to X. So here we have the formula for the area of A and B that will be given in the particular question, and also the X and X. Now we can equate this all. So if I am just thinking to divide this first two equation, that is A upon X, this equation, it's like, yes, this both we can just have a divide, that A and X, and then B and X. So dividing them over there. So changing the color to something yellow. So here I have just zoomed it a little bit small so they both are simultaneously seen on the screen. So I'm just dividing the area of A upon X. So A upon X is equals to their formula divided. So area of A is equals to half of K into its height, that is H, and area of X is half, it's, I'm talking about this and this. So its area is H into L. Now we can see over here some things are going to be cancelled, that is half and half, H and H. So we get that area of A upon X is K upon L. So A upon X is equals to K upon L. And in this both equation, that is B and X, I can again see that K and L is present and some half and height are going to be cancelled. So here I am going to take the ratio of X upon B. So if I am taking the ratio of X upon B, so area of X over here is equals to half of K into capital H, and area of B is going to be half of its base, that is equals to L, and height, that is equals to H. So H and H, half and half got cancelled out. So we get that area of X means ratio of X upon B is equals to K upon L. So here we obtain the same ratio K upon L. Here also we were having the same ratio K upon L. So as the RHS is equal K upon L, we can obtain that yes, their LHS is equal. So equating that over here, so A upon X is equals to X upon B. So from here we get that X square is equals to A into B. So from there we can have that X is equals to positive root of AB. So here we have that the area of this middle triangle, that is the triangle BED, in terms of that other two triangles. So I'm just clearing it there over there and writing all the things. If that is X, this is A, yes, and that is equals to B, and this lines are parallel, that this is parallel to that and this line is parallel to this line. Then we have that area of this middle one, that is x, is nothing but it's going to be the geometric mean between a and b. It should be small a and b. I have written capital over there. So small a and small b. So it's going to be the geometric mean between the two numbers. Under root of a b, it's nothing but it's named as the geometric mean. So in this particular question, we were having a is equals to 5 and b is equals to 8. So x is equals to square root of 5 into 8, that's 40. So x is equals to square root of 40 is the answer to this particular question. So this was my method to solve this particular equation. If you have any other method other than this, you can do comment below, or else you can DM me on my Instagram, link is in the description. And someone gives a better solution to the same question and we can show it to our viewers. It's best the knowledge.